Okay, so I am going to let you.
Yo.
I'm going to let you equal x to the fifth plus 1.
Yeah.
Therefore, du would be 5x to the fourth dx. And this matches up. So I have the integral of u to the third du, except this time I have bounds, whereas on day one, we didn't do any of them with bounds. And so if I switch to u's, I must also switch my bounds. I've got to get u bounds. Okay, so I've got x and I've got u. My x is 0 and 1. And I have an expression for u. U is equal to x to the fifth plus 1. So if x is 0, I take 0 and plug it in, and I get that u is 1. And if I plug in 1, I get 1 plus 1. So u is 2. So I've got to reassign the bounds.
Yeah.
Make sure that they match up. 1 goes with 0, and 2 goes with 1. Okay, so now I anti-differentiate. The antiderivative of u cubed is 1/4 u to the fourth, evaluated from 1 to 2. And so here's the difference. If we do not have bounds, then I took the u and substituted back in and put my plus c on there. However, if we do have bounds, we've already made the switch, so I do not switch back to x's. My x bounds stay with my x's, my u bounds stay with my u's. So here, I don't switch back to x, I just plug in my u bounds. So I'm going to plug in 2 and subtract and plug in 1. This gives me 2 to the fourth, which is 16 divided by 4 is 4 minus 1/4. So I've got 4 minus 1/4, which is 15 over 4.
So with this, you're not looking to find an equation, you're just looking.
You're getting a single numerical value because, again, when we integrate this, we are finding the area under the curve from 0 to 1. And so that is giving me an area.
So with this, after you substitute, you don't have to.
After you switch to u and you change the bounds, you just plug them in.
Okay, you don't have
Wait. Oh, no.
to- Wait, so the reason why we don't have to switch back is because of the chart that we made?
Yes.
Yeah, because of the bound. That's some good things. Yeah.
Okay, so what should u be in this instance?
X squared
X squared
minus 4.
minus 4. Therefore, du is going to be 2x dx. And it needs to be 8x dx. So I'm going to multiply by 4 on both sides. So I get 4 du equals 8x dx. Okay, so when I match these up here, I can take the 4. You don't have to do this, but if it makes it a little bit easier, that's fine. I can take the 4 and move it out. It's a constant. And I'm going to be left with the square root of u, which is u to the 1/2 du. And now I need to make me a little chart so I can switch the bounds. So I've got x, and I've got u, I've got 3 and 4. So I plug 3 in, and that gives me 5, and I plug 4 in, and that gives me 12. So I'm integrating from 5 to 12.
So will you ever, okay, so say that 3 ended up being having a greater value than 4, would you end up having to put
You can, but it still works.
Okay.
You don't have to switch the bounds. If you do switch the bounds, you just got to change the sign. Okay, but you can still just plug them in and it will work. Okay, so the antiderivative of u to the 1/2 is going to be 2/3 u to the 3/2, evaluated from 5 to 12. And so I'm going to plug in my bounds. You've got to plug in your bounds in order to get full credit. If you just leave it at this step, this would not get credit. Okay, so I plug in my 12. So I've got 4 times 2/3, 12 raised to the 3/2 minus 2/3, 5 raised to the 3/2. And this is not going to work out evenly. Like I can write that as 12 to the 1/2 raised to the 3rd power, but that gives me the square root of 12, which is not an even number, and neither is the square root of 5. So I'm just going to leave them like that. I am going to distribute the 4. Okay, so I can distribute the 4. That's going to give me 8/3, 12 to the 3/2 minus 8/3, 5 to the 3/2, and I'm going to leave the expression like that. All right, take a look at the next one and tell me what you think u should be on this one.
Ooh, I mean, I think it should be 10.
Let's try.
Wait, no. Wait, no. Yes, it'd be 10 because the derivative of du is secant squared.
Because the derivative of tangent of x is
Secant squared.
secant squared of x dx, and does that match up?
No.
It does.
Well, I need the 2 though. Just not squared.
But I'm left with what?
Yeah.
I'm left with u squared. Is that okay?
Oh, so I am the genius.
Okay, I'm left with a u squared du. Well, let's say I didn't see that and I had chosen secant. What's the derivative of secant of x? Secant x tangent x. And does that match up?
Oh.
It does not match up.
No.
This does match up, and it gives me something that I can integrate a little bit easier, except, oh no, pre-calculus. Oh,
Stop.
I've got to get u bounds, and it involves
Stop.
pre-calculus. So what is the tangent of 0?
No, she's lying. Yeah, 0.
She's not. It is 0. What's the tangent of pi over 4?
10, 1.
Over add 2.
No, it's just 1. Why not?
Oh, no, it is just.
Is it 1? Is it 1 because we've got a 45, 45, 90 triangle and the legs are the same, so it has to be 1? Or did we just memorize our trig values in the first quadrant like Newhouse told us? Or are we just throwing stuff out there and hope something sticks to the wall? It is 1. Maybe when we get to the quiz or the test, we could just skip that one, right, and take our losses.
Yes,
Okay, so now let's match up our bounds, 0 and 1. And so this is going to give me 1/3 u to the 3rd evaluated from 0 to 1. And again, I'm going to leave my trig behind. I already switched. I don't go back. Happiness is pre-calculus in my rear view mirror, right? So now I plug in the bounds. That's going to give me 1/3 cubed minus 0, which is 1/3.
Yeah.
All right, well, there is a typo on this next one. This should be the integral from 0 to -3. So I could do a U substitution on this one, but it is not necessary because I recognize that this would be a what?
Natural.
It is a natural log.
Interesting.
It's going to be the natural log of the absolute value of x plus 4. Why is it a natural log?
Because
The derivative of x plus 4 would just be 1 dx, and then I would end up with a du over u, which would give me the natural log of the absolute value. Okay, why is it absolute value? Because natural logs can only be positive. And also, what's interesting here is that I'm integrating from 0 to -3. Okay, why is this? Why did I not switch the bounds? Well, because I did not switch my variable. If I have an x here, I've got to have x bounds. If I had the natural log of the absolute value of u, then I would have to switch the bounds. But since I didn't switch, I just skipped that step and wrote it down. I keep the bounds. So now I plug these in. That's going to give me the natural log of -3 plus 4, absolute value, natural log of 1, minus the natural log of absolute value of 4.
are you gonna flip it at all?
I don't have to. I probably should mention this simplifies to the natural log of 1/4. How did that happen?
I don't know. Oh, it's a rule. It's a rule.
Oh, what kind of rule is it? Some rule that I learned in Algebra 2 or Pre-Cal or something?
Pre-cal.
I don't know.
Yes,
Did we learn this?
Oh, it's like the logs.
Oh, it's a property of logs. That like when you subtract, you divide. I should probably throw my Algebra 2 or Pre-Cal teacher under the bus, right? I was never taught that.
I don't remember that.
Oh, there we go. Now we're a little more honest, right? Maybe so. But you should probably know that
I know it.
going forward.
I know it now.
All right. Well, here, I am going to let u equal x cubed plus 2.
So it's always gonna be the denominator.
Not necessarily, but a lot of the time, yes. My du is 3x squared dx. And it needs to be just x squared. So I'm going to divide by 3. So I've got 1/3 du equals x squared dx. Okay, so that is going to give me, I'm going to move the 1/3 outside the integral. And I've got u in my denominator and du in my numerator. And so this is also going to be a natural log. But I do need to change the bounds. So I've got 1 and 2, and substituting those in, I've got 3, and then careful, 2 cubed is 8, plus 2 gives me 10. So that's going to give me the antiderivative from 3 to 10
So why
of
would
du over u, and the 1/3 is alpha.
is the 1/3 the reason why you would use the natural or change the natural one?
Yes. This is still a natural log, but it's not as recognizable perhaps as the one that we just did. Anytime you have a dx over an x, whatever that is, if the constant doesn't matter in this sense, it's going to be a natural log. But this is also. Okay, so this is going to give me 1/3 times the natural log of the absolute value of u, where it is evaluated from 3 to 10. So this is going to give me 1/3 the natural log of 10 minus 1/3 the natural log of 3. Can drop my absolute value because both of the bounds are positive. I guess I could simplify this also, right? I could leave the 1/3 out front and then have the natural log of 10 over 3. But you get the idea. Well, what about this though? How is this one different? Let's say this one's almost the same. Let's say I have the integral from 1 to 2 of x squared dx over x cubed plus 2 raised to the second power. How would that change it?
Wait, what is it?
It's not going to be a natural log. How about you work it out?
Stop.
We got it. Go for it. Our u is not going to change, all right? U is still going to be x cubed plus 2, and du is going to be 3x squared dx. I'm still going to divide by 3. And my bounds are going to be the same. What will change, however, is I will have du over u squared. And so that was one of my rules, like rule number 4, common mistake alert. This is not going to be a natural log because my degree in the denominator is not 1. Instead, I'm going to write this as 1/3 the integral from 3 to 10 of u to the negative 2 du. So now I need to anti-differentiate u to the negative 2. So I add 1 to my exponent, which gives me u to the negative 1. And then I divide by negative 1. So let's see. I've got negative 1/3 u to the negative 1 evaluated from 3 to 10. And this is going to give me negative 1/3 times 1 over u evaluated from 3 to 10. So I need to plug in my 10. That's going to give me negative 1 over 30 minus a minus. So plus 1/9. Oh no, a common denominator.
Wait, sorry.
What's my common denominator of 9 and 30? There's a smaller one.
Wait.
There's a smaller one. 90. How about that? So that's going to give me negative 3 over 30 plus 10. Excuse me. Negative 3 over 90 plus 10 over 90, which is 7 over 90. Whew. We need a stretch break.
No.
We're just gonna push on through. We're just getting started, Newhouse. Double time. Triple time. All right, here we go. Well, what is u? Let's make it sine of x. And du is cosine of x dx. Therefore, I have the integral of u squared du, But oh no, pre-cal was not merely in our rear view mirror. It has reared its ugly head again. And so now I gotta find what is the sine of pi over 4? It's 1 over radical 2, or I could rationalize the denominator, right? And get square root of 2 over 2. Well, what's the sine of pi over 6? I don't know. I'm just gonna skip that one on the test, right? I mean, who needs trig values in the first quadrant? Is it?
Yeah.
Is it 1/2?
Yeah, when you use your fingers.
Are we sure?
Yeah.
All right. If you say so, it's 1/2. So let's see, I gotta match these up. That's gonna give me 1/2 and square root of 2 over 2 here. Antiderivative of u squared. 1/3 u cubed. Evaluated from 1/2 to the square root of 2 over 2. So now I am going to plug in my bounds, which gives me 1/3 square root of 2 over 2 to the 3rd power minus, let's see, 1/3, 1/2 raised to the 3rd power. I don't know. I'm feeling like leaving it. What do y'all think?
Yep.
Motion seconded. Motion passed. Let's move on with our mathematical lives. All right. So what is u on the next one? Okay, if it were, it's not e to the x, but if it were e to the x, what would my derivative be? And does that match up with what I got? It doesn't, so it's not that. Well, if it's x squared, what's my du? 2x dx, and that could match up if I divide by 2, and I'm left with just the integral. I'm going to move the 1/2 out front. The du divided by 2 is 1/2, and I move that out front. It's a constant, and I'm left with e to the u du. But I got to switch my bounds. I've got x, and I got u, 0, and the square root of natural log of 4. I plug 0 in, 0 squared 0, and this one's going to be natural log of 4. So I'm integrating from 0 to the natural log of 4. What is my antiderivative of e to the u?
E to the U.
It's just e to the u. It's the same because my derivative of e to the u is e to the u. So I've got 1/2 times e to the u evaluated from 0 to the natural log of 4. And now I'm going to plug in my bounds. You got to plug in the bounds to get credit. And that's going to be e raised to the natural log of 4 minus 1/2 e to the 0. And this is a question that would probably be like on a multiple choice, because this will simplify like to a single number. So what is e raised to the natural log of 4? It's 4. And 4 times 1/2 is 2. And e to the 0 is 1. So I got 2 minus 1/2, which is 3/2.
Oh, we did it.
All right. Well, what's my u in this case? Cosine of x. And my du? It's what? Cosine of x is, derivative is?
We have to
negative sine of x. All right, so I gotta get rid of this negative by multiplying by -1 on both sides. So I'm going to have a negative outside my integral. And then I'm going to have e to the u du. And pre-calculus again. X, u, I've got 0 and pi over 2. What's the cosine of 0? I can't ever remember. It's 1?
Oh, yes, it's 1.
It's one.
We're positive?
Positive.
Hold on, let me draw the unit circle. Cosine. Okay, it's 1.
Yes.
What's the cosine of pi over 2?
Cosine power 0.
It's 0? We're positive? We're just gonna skip this one too. I mean, we skip so many now, our GPA is probably gonna be affected, right? We're just gonna go with 0. Okay, so now I've got the antiderivative, the negative antiderivative from 1 to 0 of each du du. And again, I could switch the bounds. If I did that, I would change the signs, but you do not have to. It will work out. Okay, so that's going to give me negative e to the u evaluated from 1 to 0, which is negative e to the 0 plus e to the 1. Plugging in my bounds and subtracting. I've got a negative e, a minus minus, because I subtract there, right? And so e to the 0 is 1, so I've got a -1 plus e. So e minus 1 is my final answer. Whew.
We're done.
Oh, but we've already skipped so many that involve trig. I mean, I can't just skip the last one that says, what do you do if u sub won't work? I mean, I've got to build up a skip bank, right? There's going to be some that I'm not going to know how to do. And if my skip bank is empty, then I could just take one for the team and skip this one, right?
I don't like how little boxes
Well, let's take a little stroll down amnesia lane, shall we? Here we go. Let's say 2 divided into, how about 357? Just bear with me for a second. Little, what is this? 5th grade math? All right. So 2 goes into 3
One time.
one time. And then I multiply 1 times 2, which gives me 2. And what do?
Bring down the 5.
Wait. I subtract first, right?
Then you bring down the 5.
So then I bring down the 5. And 2 goes into 15.
7 times.
All right. So 2 times 7 is 14. And subtract 1. And then
Bring down the
I
7.
bring down the 7. And 2 goes into 17.
8
8 times, and that's going to give me 16. And I got a 1. And uh-oh.
Remainder of 1.
I got a big R, right, for the remainder. Or I guess I could write this as plus 1/2.
Where do you get the 1/2 from?
2 goes into 1. That's what's left over. It's a
So
remainder of
let's say
1.
that 2 was a 3, it would be 1/3.
Yes. I'm pretty sure when you were in 5th grade, you complained about division, like this is so hard. Well, I'm writing it like that for a specific purpose. Because look at this. I will save you some time here. Shh. I will save you some time. U substitution is not going to work.
Wait, wouldn't you?
I mean, you could be x plus 4, but
Wait, why can't you just like factor out the top? No, never mind, because, no,
what are the factors of 7?
exactly.
Oh. And then you could be x squared minus 3x plus 7, but then the du, I'll save you some, it's not gonna work. So like, what does that line mean in the middle? It means divide, so here we go, we're going to divide.
Oh, I forgot how to do
Woo! All right.
Chill out.
This is unusually
what?
right.
This is amnesia. That wasn't amnesia. This is.
My algebra teacher never taught me this.
No, it's-
Okay, so here we go. What do I multiply x by to get x squared? X. So that's going to give me x squared plus 4x, but over here, I subtracted, right? So I've got to change the sign here, subtracting. That's going to cancel. And I've got negative 3x minus 4x is negative 7x. So now what do I multiply x by to get negative 7x? Negative 7. So let's see, that's going to give me negative 7x minus 28. But then I've got to subtract, so the sign is going to change. And I'm going to bring down the 7. 7 plus 28 is 35. And what do I multiply x by to get 35? It doesn't work, so this is my remainder. So I might write this as plus 35 over x plus 4. You're probably wondering, how does that help us? A great deal, actually, because now I can write this as the integral of x minus 7 plus 35 over x plus 4 dx.
Oh my gosh.
And now I'm going to integrate each of these separately. What's the antiderivative of x?
1/2 x.
What is it? 1/2 x squared. What's the antiderivative of negative 7? Negative 7x. Integrating each one of these separately. Well, what about this one? Can I look at it and do the same thing?
No.
Actually, I can because, hold on. Let's go back. Look at that. This is almost like the same problem. It's dx over x plus 4. And what happened? It became the natural log of x plus 4. So I can like move the constant out. I can move the 35 out. Wait,
So wait, multiply the whole thing by 30?
hold on.
Wait a minute.
I'm integrating each of these separately. So let's say I have the integral of 35 over x plus 4 dx. So I could write this as 35 times the integral of dx over x plus 4. All right. And what's the antiderivative of this? So it's going to be 35 times natural log absolute value of x plus 4. So plus 35 ln absolute value x plus 4. And even after all of that, it's still not completely right. Why not?
You don't have any bounds.
Let's see. Oh
So
my
if I
God.
don't have any bounds, I better have a plus c.
That's in
Whew.
Sorry, I'm gonna get you all. And I'm gonna forget the plus C. You're gonna count.
I don't wanna get